Now in this lecture, we'll see handling multiple devices. So multiple IO devices are connected to the processor through the system bus. Now in this lecture, we are going to analyze a few points like how the microprocessor knows which device has generated an interrupt. And also microprocessor knows which interrupt service routine need to be executed. Now, if the microprocessor is executing an interrupt service routine for one device, can other device interrupt the processor or not? If more interrupt service requests are received simultaneously, then how to break the time? Now, these are the points we are going to analyze under handling of multiple devices. Now, in this already you know that here all the devices are connected to the microprocessor through the interface that already we have discussed in the last class. In this interface circuit, it is having the address decode register, data register, status register, and control register. Now, in this status register, one of the bit is IRQ, nothing but an interrupt request bit. Now, microprocessor, when it receives the interrupt, when it is receives the interrupt, then microprocessor will read the status of all the interfaces circuits of status register. Now, whichever the status register IRQ bit is equal to 1 or IRQ bit is enabled, so microprocessor understand that particular device is generated the interrupt. Like that microprocessor, no, it is reading the status of all the interfacing circuits. That is nothing but polling mechanism. It is very easy but time consuming. So for that, reduce the time, we have one more method, vector interrupt. Now in this device, requesting an interrupt may identify itself directly to the processor here. If one device is connected to the processor, then when it is generating the interrupt signal, then microprocessor is receiving this interrupt signal. Then along with this interrupt, this device is also sending the vector code. The special code is nothing but what? Vector code. It is having 4 to 8 bits of 8 bits. So with this code, microprocessor reads the starting address of the ISR. Thereby, it will execute that particular ISR. Here, microprocessor no need to check all the status bits of the interfaces. So whenever it receiving the interrupt signal, then automatically interrupt signal is placed on the control bus. Now, whenever it is receiving the interrupt signal, microprocessor sends the acknowledgement to that particular device. Then the device itself sends the vector code onto the data bus. It will place the vector code onto the data bus. So that vector code, with that vector code, it will detect the starting address of the ISR. Now, this is one of the method is interrupt vector table. It is saved in the memory. For this, now here it is for every code, for every code, it is mentioned here, it is mentioned the starting address of the ISR. So if it is receiving the code, then particular code, what is the starting address of the ISR, it will read from the memory and it will execute that program. This is one method. In few microprocessor, this special code, vector code itself is nothing but a part of the starting address. And the remaining address is obtained by the processor based on the information such as range of memory addresses where the interrupt services, interrupt routines are located. It is similar to the interrupt vector table only. So this code is nothing but a part of the address, and remaining part of the address is placed in the the interrupt vector table. Now, like this, the device itself is sending the address, starting address of the ISR. Now, interrupt nesting. Now, if a microprocessor is executing one ISR, in between, if any other devices is requesting or if it is sending the interrupt signal, then microprocessor, whether it accepts or not. In a previous topic, enabling and disabling, we have seen that whenever microprocessor is executing this ISR, it disables the interrupt. Thereby, if any IO devices are sending the request, microprocessor will not accept that request. But Why? Because why it will not accept means ISR for execution time of ISR is very, very less. And this will be considerable time for the devices. But in few cases, this time is this small execution time is also not considerable for few circuits like now real time clock. Real time clock, if you take, it is having the hours and minutes, seconds counters. Now, for every intervals, it's supposed to increment these values. So, for that, if any, now, for example, if keyboard or printer ISR is being executed, now if it is taking some time, that time, if the real-time clock is generating the interrupt signal, then microprocessor is supposed to accept this interrupt, and it's supposed to suspend this ISR, and it will go to the ISR of real time clock, and it will execute this program. Again, it will come back to the ISR of the first program where it has stopped, and it will execute the remaining instruction. And after completing this one, again, it will go to the main program. Like this, in between ISR, it is accepting the interrupt of other input, other IO devices. Now here the importance already I have explained. Now this happens only when the uh, priorities are given to the devices. Now, if the first device priority is less than the second device priority, then it will stop executing the first ISR and it will accept the interrupt of the second ISR. So, executing the uh, uh, accepting the interrupt in between the ISR of one device is called the interrupt nesting. Okay, in between now, one ISR is being executed in between another ISR. This is called the interrupt nesting. And these priorities can be assigned. Now, this happened only when the devices are given the priorities. And these priorities can be assigned by using the privileged instruction. These privileged instructions are nothing but now if you take one system can be operated in two modes. One is user mode. Now, what we are doing now, I am teaching the class and you are listening. This is nothing but in a user mode. And another mode is supervisor mode. In this mode, OS related programs will be taken care. So, in that, if in a supervisor mode, by executing the instructions, privileged instructions, we can assign the priorities to the devices. Now, this is if how the diagram for the multiple priority scheme. If the devices are giving the priority, then how the processor will execute that interrupt, we will see in this topic. Now, device 1, device 2, up to device P, devices are connected, and each device is having its own interrupt request line and interrupt acknowledgement line. And if all the devices are priorities are now, every interrupt request is having its own priority. Now, if all the devices are generating the interrupt, all will be polled by the priority arbitration circuit. Now, here it will check the priority and which is having the highest priority for that device, it will send the acknowledgement signal. Now, after that, that ISR will be being executed. Now, this is how the now if for example if device 1 and device 2 both are requesting for the service, if device no at the beginning, if the device 1 is requesting for the service, and if the after getting the acknowledgement, device 1 ISR is being executed. At the time, if the device 2 is sending requesting for the service, if the device 2 is having the highest priority than the device 1, then microprocessor will stop executing this ISR, and it will jump to the ISR of device 2. And after executing this, again it will come back to the device 1 ISR and it will finish, and after that it will go back to the main program. Like this, it will handle the multiple priority scheme. Now, in the previous lecture here, if you see, more number of connections are there. Each and every device is having its own interrupt request and interrupt acknowledgement. And also one more problem is which is having the lowest priority, the device may not get the chance for the uh, um, execution of the program. So for that, now here one more method is to avoid the more number of connection. Now single line is there for this, all the devices are connected. Now, if the microprocessor is receiving the interrupt signals simultaneously, then how it is going to break? That we are going to see here in the daisy chain scheme. Now here, interrupt, only one interrupt line is there. All the devices are connected to this interrupt line. But whenever the device is requesting the interrupt, that will be placed on the interrupt. And whenever the device is placing the interrupt, microprocessor receives the interrupt. Thereby, it will send the acknowledgement signal to the first device one. So if the device one is already generated the interrupt, then this acknowledgement will be blocked by the device one and it will place the vector code onto the data bus. Now it will place the vector code onto the data bus. If the device one is not requested, not generated the interrupts, then this INTA is passed to the device 2. If the device 2 is already generated, then it blocks the INTA interrupt acknowledgement and it will place the vector code onto the data bus. After receiving the vector code, then the processor will execute this ISR like that. So whichever the devices are sending, so one by one after the other, the INT request signal acknowledgement signal will pass to that device. So now in this, whichever the device is connected electrically close to the processor, then the device is having the highest priority, which is far away from the microprocessor that is having the lowest priority. In this device one is having highest, next highest is the device 2 and device n is having the lowest priority. Now in this also, here the connections are very less and easy, uh, but device n may not get a chance to execute its program. So to avoid that, now we are going for the combination of priority structure and daisy chain. Now here the group of devices are connected together and here also you can see group of devices are connected and these groups are given the priority. So depending upon the priority, microprocessor will give the acknowledgement to that. And again inside, now for example, if more than one device is generated, now first group is having highest priority, then it will receive the acknowledgement. And this will, inside this group again, the daisy chain system will follow. So if the device one is generated the request, then this acknowledgement will be blocked by the device one. Otherwise, it will be passed to the next one. Like that, here, many devices may get the chance for the interrupt. Now, like that, microprocessor will handle the multiple devices.